We will now look at the delete method for the single linked list class. Again, as you can see in the heading of the method, it returns a boolean true or false whether the delete method was successful in deleting the element or not. The first line of code there, it creates an element pointer and it just references the head. So there's my element pointer and it references my head. The idea of this pointer, the pointer that points to head and my previous pointer, is basically used to iterate through a single linked list. So I'm just going to talk you through it a bit. There we have the while, and the test condition there is while pointer not equals null. So we will advance this pointer until it reaches the last elements. Next will point to null, so basically until it points to null, and then it will kick out. So then it means that I've iterated through the whole list. So if you think of an array, normally an array we start at index 0 and we advanced it by saying the counter plus plus if you use a counter to refer to the index of an array. Here we use an element which is basically a reference to the first element in the list, and that's normally the head. We call it pointer in this case, but as you can see it is used to iterate through the single linked list. Okay, so yeah, that is how it works. So let's see how it will work by looking at a couple of examples. I've just typed some code here at the bottom to represent the driver program. So here I create a single linked list, then I append a 3, a 4, a 7 as integers, and then I want to delete the integer with the value of 5. So if we look at the code, we have our pointer, it is now equals to head. Our previous pointer is not referenced, it is null. So then our while loop there, while pointer not equals null, our pointer is not null because it refers to an element, so that is fine, and it has an AND condition. Both of these need to be true for the while loop to continue, otherwise it will stop. So then it will check the second part of the while loop there, pointer.data.compare to item. The item that we received here as parameter will now be compared to the data of the element where the pointer is pointing to. Note that we use the compare to, which basically means we want to use or compare the value of that integer with the value received here as parameter and not reference. If you just say here pointer.data equals to item, then it means that both the item and the data needs to have the same address, or it must be the exact same object, otherwise this condition will not true. In the case that I want to show you now, we want to compare it by value, so it can be another integer as long as it has the same value, then this will hold true, and that is why we use the compare to method there. Okay, so in the example I want to delete the integer with the value 5. As you can see, there's no value of 5 here. So the first one there, the pointer points to this element, the data has a value of 3, it will compare the value 3 with the value 5, and this will not be true. So then I need to advance my previous pointer, so my previous pointer here will now reference to where the pointer was referencing to, and now my pointer needs to advance. The next line of code there, pointer equals pointer dot next, and this is the same as in a array where you have counter plus plus. The pointer equals pointer dot next is how you move forward when you iterate through a linked list. Okay, so now we will check the value of that data, which is 4. We will compare it with the 5. Is it the same? No, it is not. So again, we need to advance. So my previous pointer will now come to this element or refer to this element, and my pointer will now move to the next. So the next is pointing to this element here, so now my pointer will basically point to that. Okay, so again I take this data, it has a value of 7, I compare it with the item that I've received as parameter there. 7, is it the same as 5? No, it is not. So again, I will iterate. So previous pointer equals pointer. So this will now refer to the element where the pointer was referring to. And pointer equals pointer.next. So this one dot next is pointing to null. Thus my pointer will now be pointing to that same null. Okay. So the test condition for my while loop, while pointer not equals null, no longer holds true because now it is null. So it will kick out. So next line of code there, if pointer equals null, return false. So our pointer is equal to null, so it will return false. Just basically indicating that the integer with the value 5, it is not within my list. So I'm just going to reset this so that we can try this with another value. The next value that I'm going to provide it is 3. So let's see how this will work. So again, my pointer starts at head, my previous pointer starts at null. While pointer not equals null, my pointer is not equals null, so that's fine. Pointer.data.compare to, so I take this data, the 3, I compare it with the 3 which was received as argument there, item, they are the same. Okay, so the for loop, or the while loop, sorry, will kick out. It will check this. If pointer equals null, this is not true, so the next part there, if pointer equals head, this is true because the pointer and the head both refer to the same element. So now it will execute that code. Head equals pointer.next. So this element, where is its next pointing to this element? So my head equals pointer.next basically means that the head will now refer to this element. Okay. The else condition will not execute because it's part of the else. And then I say if pointer equals tail, my pointer is not equals to tail, so that will not execute, and then it will return true. So basically, as you can see, I still have the linked list, but my head is now referring this to be the first element within my single linked list. Thus this element class here is effectively removed. Okay, so I'm just going to reset this again. So let's take another scenario. Let's say we want to remove 7, which is our tail. Again, element pointer equals head, so we create the element pointer, and that will be referring to my head. Okay. And my element previous pointer is still pointing to null, so my while condition, while pointer not equals null, my pointer is not equals null. Then I say pointer.data.compare to, so I take my data, I compare the 3 with the 7. Are they the same? No. So then I'm first going to say previous pointer equals pointer, so my previous pointer must now refer to the same element as where my pointer was pointing to, and my pointer also needs to advance by calling this pointer equals pointer.next. So where's the dot next pointing to? There. So my pointer needs to move to that element. Okay. It will take this data and compare it with the 7. It is not the same, so again I'm going to advance my previous pointer, and again I'm going to advance my pointer. Other way around, pointer must come this side, previous pointer must go there. There we go. So again, now I'm going to compare the 7 with the 7. So is the data, which is an integer, is that value the same as the value passed as argument? Yes, they are the same. So the while loop is done. It will check the first condition, is pointer equals to null? No. If pointer equals head, no, my pointer is not the same as my head. So the next part there is the else part there. So previous pointer dot next equals pointer dot next. So previous pointer, so this is this element, dot next equals pointer dot next. So basically this one here will now be pointing to null. Okay. So the next part of the code here, if pointer equals tail, tail equals previous pointer. So is my pointer the same as my tail? Yes, it is. So my tail now needs to point to where the previous pointer is pointing to. So previous pointer is pointing to there. So this one now must point to there. Okay. So as you can see, effectively this element has been removed from the list. Okay, I'm just going to reset it again for another example. So my previous pointer, I'm going to move it there, my pointer, I'm going to move it there, and this one here is still referring to that one there, like so. So let's say we want to delete something in the middle of our list, so let's make this 4. Again, our pointer will start off being equals to head. Okay. The while loop, our pointer is not equals null. Pointer.data, the 3, is it the same as 4? No, it is not. So it needs to advanced. So my previous pointer must point to that element, and my pointer can advance to where pointer equals pointer.next. Okay. Then it checks again, is the data the same as 4? Yes, it is. So the while loop is done. So the next part of the code, if pointer equals null, no, my pointer is not equals to null. If pointer equals head, no, it's not equals to head. So else previous pointer.next equals pointer.next. So previous pointer.next equals pointer.next. Basically this means I'm going to skip it all the way and go to pointer.next. Okay. And then I'm going to say here, if pointer equals tail, no, it is not equals to tail. And then I'm going to return true. So as you can see with this part of code, previous pointer.next equals pointer.next, I basically skip this element. So it's no longer referenced in any way. So effectively it has been deleted. And that is the delete method for the single linked list class.